So in this very short lecture, we are going to talk about how to compute the n root of a complex number. So I say the title is the nth root, the n root of a complex number. Okay, so what are in a previous theoretical lecture we saw what is a complex number, and we saw that a complex number is a number in the form z plus ib with a belonging to r and b belonging to r, right? This is the algebraic form of the complex number. Now what if I ask you to compute cubic root of a plus ib? So a cubic root of, for example, what if I ask you to compute the fourth root of 1 minus ib, or 1 minus I, or I may ask you to compute the sixth root of 1 plus 3i, or even the fifth root of I? Yes or not? So this will be the cubic root. This is the fourth root, the sixth root, and the fifth root. But basically, the question here is to say that this means that if I ask you to find, for example, okay, find let's say that w is a complex number and I want to find the n root of w. So we can consider that w is a complex number and we want to find the n root of w. When you try to do this, you get exactly n different numbers, n different complex numbers. I repeat, so the n roots of any complex number are exactly n different numbers. Is that clear? So when I do the n root of any complex number, I will get z1, z2 until zn, n numbers. To be clear, if I ask you to do cubic root of 1 plus I, how many number you will get? z1, z2 and z3. So the first thing that we say here is that the n root of any complex number are always n. Okay, this is the first thing. Now look, another, I can, when I say, for example, when I say solve, when I say, for example, z to power 6 equal to 1 plus I, what does it mean? This means z equal to what? To 6 root of 1 plus. So this equation means find the sixth root of, find the sixth root of 1 plus I. Yes or not? So this is another way. I can write it like this, or I can write it like that. Okay? Or even I can give you an equation like 2z squared minus I equal to 0. Note that this means z squared equal to I over 2. Yes or not? And that z is square root of I over 2. So this will be, there will be two numbers. Yes or not? z1 and z2. So even this equation corresponds to finding the square root. Yes or not? Now if I give you an equation like this one, z cubed plus z minus I equal to 3, does it correspond to, this is z, this equation corresponds to finding some roots, to finding cubic roots? Yes, because this my student is saying that the equation does not correspond to finding the cubic root because of this z. Yes or not? This, if I can z cube, if I write z cube, it will be 3 plus I minus z. Yes or not? So these are not the cubic root. We are not finding for cubic roots because there is this z. We are not finding for the cubic root of some complex number. So you should be able to recognize if you are finding for the n root or not. when the equation is such that you can write it like z equal to n root of some complex number, then you are finding for the n root. This should be a complex number, it should not be unknown. It's clear? To make sure that you are finding for n root. For example, if I write z to power 4 plus 8 equal to 0, it means z to power 4 equal minus 8, and then z to power 4 equal z equal to 4 root of minus 4. Here I am finding the fourth root of minus 8. Is that clear? Now that we understood how many n root we have, and we understood when the equation is asking us to find the n roots, let's see how to compute the n roots. Okay, it's easy to do it with an example. Okay, let's try to solve the equation z to power 4 equal 1 plus I. Okay, so this equation, it is asking us to find what? Because we can rewrite it like z equal to the 4 root of 1 plus I, and thus the equation is asking us to find the fourth root of a complex number. Yes or not? So for us here, the complex number w is 1 plus I, and we are finding no. Okay, the question of my student is that, is there in this case, do we care about positive or negative inside the square root? For okay, no, but in this case is not the case. This is not the case. The question of my student was that, as in when we are in R, when we say x square equal to 1, then we say x equal to plus or minus the root of 1. But the strategy that we use in complex number allow to get directly all the roots, so we don't need to put plus or minus. Okay, so we know that the exercise, the question here, so z equal to 4 root of 1 plus I, we know that there will be exactly 4 solutions, right? z1, z2 until z4. As I told you that the n root are always n. Now, how to find this 4 solution? What are we looking for? We are looking for z, right? To do that, we write z in the trigonometric form, because we say that z is some r times exponent ri t. We need to find the r and we need to find the theta. Yes or not? We also write the 1 plus I. We also write 1 plus I in the trigonometrical form. So we have 1 plus I. So A is 1 and B is 1. So R, the R will be square root of 1 square plus 1 square equal to square root of 2. Right? This is for the radius, the modulus. And the theta for this 1 plus I, theta will be r tan of just 1 over 1, because we'll use r tan of b over a just without the plus pi, because a is positive, right? So r tan of 1, it will give me r tan of 1, and that I told you is to be pi over 4, right? So we saw that 1 plus I is actually be written, we can write it as root 2 exponential of I pi over 4. This is the two. Okay? Now, when you are solving this kind of equation, when you know when you write down the trigonometric form of z, you write down the trigonometric form of the w, of the number you are finding, whose number of the number for which we are finding the fourth root. You come back to this. This is we know that z to power 4 should be 1 plus I, right? This means that z to power 4 means that r exponential of I theta to power 4, this is z to power 4, right? Should be exactly this number, should be equal to this number. So it should be root 2 exponential of I pi over 2. Okay? You remember that your goal is to find r and theta to get z, because you need r and theta to get z. Yes or not? So this equation gives you r to power 4 exponential of I 4 theta is equal to root 2 exponential of I pi over 4. Now we can proceed by identification. We put number together and the exponential together. From this you can directly see that r to power 4 is corresponds to root 2, right? And thus 4 theta corresponds to pi over 4. Yes or not? But we say that anytime we write an angle, we have to because I don't care if I add do I care if I add a round on it? It's the same angle, right? But this is a single round. This 2 pi is a single round. But I don't care even if I add any k rounds. You got it? So then we reach that r square is going to be r is going to be the 4th root of root 2. Yes or not? You agree? And then theta is going to be pi over 16 plus k pi over 2. You agree? Is there any doubt? Okay, I just divided by 4. So now look at the formula that we reach. Now when you reach here, k is any number of round, we said, right? But we are finding for the 4th root. Yes or not? If you are finding for the 4th root, you will choose the value of k going from 0, 1, 2 and 3. Okay? If you are finding for the n root, you choose the value for the n root, you choose the value for k going from 0, 1, 2 until n minus 1. So let's find the first solution. The first solution is z1. It is the solution that corresponds to k equal to 0. It will give what? Look, z is r exponential of I theta, right? We know that the r, so it will be 4 root of root 2 exponential of I. What is my theta here? If I put k to 0, theta will be pi over 6, right? Pi over 16. So this is the first root. Okay? Now the second root will be the same r. But now exponential of, now I will take k to be 1. Yes or not? That will be pi over 16 plus pi over 2. Any question? What will be the third root? The third root, now it will be root 4 of root 2 exponential of I. What do I get? That's like this. Okay, no problem. Okay, we continue. Is there any question, Ahmed? So if we put k equal to 2, we will get pi over 16 plus, normally this is 2 times pi over 2, right? So it will 2 times pi over 2. I can write it like pi over 2 plus pi over 2. Yes or not? Okay, I know why I'm right. So z4, the last one, will be the 4 root of root 2 exponential of I multiplied by pi over 16. Now I have to put 3 times pi over 2, right? Let me write like pi over 2 plus pi over 2 plus pi over 2. So these are the 4 solutions of my equation. These are the 4 root of 1 plus I. Is that clear? Why? How can we? What do you see? We see that when all the roots have the same modulus. Yes or not? They all have the same modulus. Look, the modulus is this one. They all have the same. Okay. What does it mean? When two complex numbers has the same modulus, they belong to the same set. because remember that the modulus is the distance from the origin. So if I take z1 and z2 that have the, if two complex numbers have the same modulus, they will be on the same circle. Yes or not? Doubts? This means that when you have, anytime you solve the equation z to power n equal to w, where w is another complex number, this equation is equivalent to solve z equal to n root of w. The n solutions have the same modulus. Okay, the n solution has the same modulus, and this modulus, the common modulus of the n solution, so the modulus of any solution will just be the n root of the modulus of this guy. Is that clear? I am saying that anytime you solve, you find the n root of a complex number, these n solutions have all the same modulus, and that common modulus is equal to the n root of the modulus of the number whose n root you are looking for. For example, look, if I ask you to solve cubic root of I, what does it mean? It means that I am asking you to solve z equal to the cubic root of I, right? So here you are looking for the cubic root. There will be three solutions, z1, z2 and z3. The modulus of z1 will be the same as the modulus of z2, will be the same as the modulus of z3, and it will be the cubic root of the modulus of what? Of I. But the modulus of I is 1. So this will be the cubic root of 1. That will be 1. Is that clear? So all these three solutions will have modulus equal to 1. So I was saying that this is the first thing. Even let's say that it's the second. The first thing was that anytime I solve the n root, I get exactly n solution. We also saw that all this n solution has the same modulus, and thus they stay on the same circle. They stay on the same circle. The modulus, the common modulus that they has is the n root of the number whose n root we were looking for. Okay. And finally, let's go back on our solutions. What is let's represent z1. The first solution that we got. So we want to represent the fourth solution that we got. Let me draw a circle. What is the modulus of, look, as the modulus of this number is 4 root of root 2, right? They all have the same modulus. So the radius of this, if I want the solution to stay on this circle, the radius of this circle will be exactly the 4 root of root 2. Yes or not? And here, this angle here will be pi over 16. The first, you see? Yes or no? This is the first solution. I represent its modulus and its angle, and this is z1. Now look, what is the angle? So from the angle of z1, how much should I add to get the angle of z2? Pi over 2. So the angle of z1 is pi over 16. The angle of z2 is pi over 16 plus pi over 2, right? So I have to add pi over 2. Yes or not? So I just add pi over to this angle, and I get here, yes, z2, right? Then to get z3, what do? I just add what? To get z3, I take, this was the angle of z1, This is the angle of Z2, right? So the angle of Z2, I just still add pi over. So starting from the angle of Z2, I just add to get the angle, to get Z3. Now to get the fourth solution, I start from the angle of Z3 and I just add pi over 2 and I lead here, right? What do you notice? You notice that the fourth solution are this, and this. Okay, we notice that the four solution are the vertices. So at the moment, the four solution are the vertices of a square, right? Of a square. This is a general problem. So, and how, look, the total circle, the total circle is 2 pi, right? And we were and looked at this four solution. When you do 2 pi over 4, how much you get? Pi over, exactly. So, and what happened? It happened that each solution divided the circle. When you are looking for the fourth solution, you divide the circle exactly in 4 parts which are equal, because remember that every step was pi over 2. If I am looking for the cubic root, okay, cubic root of W, the circle will be, the step will be 2 pi over 3. It means, for example, that if I know the first solution, suppose that I get the first solution that is here, okay? If Z1 is here, I just need, starting from Z1, to divide the circle in 3 parts which are equal. Yes or not? I should divide, if Z1 is here, the second one will be maybe here, and the third one will be here. Yes or not? And the 3 solution in that case will form an equilateral triangle. Okay, so what is the output of all this? The output of all this is that if I find the end roots will belong to a circle, okay, and they will be the vertices of they will split the circle in n equal parts. Okay, anytime I find the n root of a complex number, so anytime I do n root of some complex number, I get n numbers, Z1, Z2, until Zn. They all have the same modulus. Okay, this same modulus is equal to the n root of the modulus of double, and they all belong to the same circle, and the radius of the circle, also the radius of that circle, is the n root of the modulus of W. Is that clear? And finally, they split the circles in exactly n parts which are equal. Yes or not? When you go back here, if the first solution is here, the order we split the circle is exactly in n parts which are okay, and then as they split the circle in n parts which are equal, they are the vertices of a regular polygon. Okay, nice. This let's say that this concludes our lecture about the n roots, and I hope you enjoyed it. Okay, so we next time we continue solving MCQs.